Hello everyone, today I'll be teaching you the exact form of the differential equation. So if you have a differential equation in the form of mx y dy plus nx y dx equals to 0, this will be in the exact form if this function can be represented as a derivative of a function x y. So let's try an example. This is in the exact form as it is the derivative of xy. I've showed you guys this example in the introduction to differential equations, but I'll review it again. Since here, if you differentiate xy, what you'll get is x dy by dx plus y dx by dx, which is 1, equals to 0. And here you can multiply dx on both sides, so you'll get x dy plus y dx equals to 0, which is this. So x dy plus y dx is an exact form. So the problem about exact form is that you will need to know the derivative of something by pattern recognition. That means you have to practice more and more to see what is the derivative of this function. So let's try another function or another differential equation. You guys can try this at home and I'll be writing the answer now. So here one pattern or one thing you can consider is if you have something, a function of x dy, then you should always consider that function, the derivative of that function y. So here you should take the derivative of x square y. So what this gives is 2 y x square dx square by dx plus x square dy by dx. So here this is just y into 2x plus x squared dy by dx equals to 0. And again we can multiply dx on both sides, so we'll get 2xy dx plus x squared dy is equal to 0, which matches with that. So this is in fact the derivative of x squared y. Now of course you can integrate both sides and you'll just, the integration and derivative will cancel. So you'll get x squared y. Well, this is just a constant. That is the general form. So I'll be writing down the basic ones, the basic exact forms. So I've just written two, I'll write another one as well. Now here, the problem with this is we have a minus in the middle, because if we want a derivative of function x into y, then we'll get a product rule. Then we have to use the product rule in which we have a plus in the middle. But what about a minus? Well, if we have the quotient rule, then we'll get the minus in above. V, the derivative of u by v is v du by dv minus u dv by dx whole by v square. So here, let's see. Since we have v du by dx by, and that the remaining by v square, and we have a y, let's just divide everything by y square. So 0 divided by anything is 0, so we can just leave it as that. And we can see here, this is the derivative of x comma y, x by y. Since you'll get y dv by dx, which is just 1, minus x dy by dx by y square. This will be equal to 0, and you can also multiply dx on both sides, and what you'll get is just that. So this is in the exact form. Without the y square, y dx minus x dy is in the exact form. So a tricky one is the exact exercise number 15.4, the first question. even the first question itself is tricky, since you have y dx minus x dy is equals to xy dy. Now here, let's just separate put this on the bottom. We know that we want y over here, so we can multiply the numerator and denominator by y. So this is y into y dx minus x dy by y square equals to dy, and this x, let's put it here. So here we know that this is the derivative of x by y, but what about y by x? Well, you can write, well, this is another pattern recognition. If you have another function on here, then you should always check the log of this function. So here, log of x by y, first of all, if you use the chain rule, you'll always get 1 by x by y, which will give you y by x into the derivative of x by y dx, which we have over here. So in fact, this whole thing is equals to the derivative of the log, natural log of x by y, which is equals to dy. So, and if you want to solve this, then you can simply integrate both sides, and this cancels, so you get ln x comma y is equals to y plus c. Now you yourself have to practice in order to know the different types of pattern and the different types of approach you have to take in order to solve these types of equations. Now in the exam, you'll only be given a differential equation and have to solve it. You can use any method you want, and in some of the exercises, you can use the variable separation method directly instead of the exact form, which will just take your brain power. But some you have to use the exact form, such as the first, no, not the first, but some which have a total, which you have to use the exact form to find a derivative and then integrate both sides. Thank you.